Today we will review this board, SpeedVal Kit. This is the code of this board that we will describe. This would indicate modular platform, MOD, so then the type of this board. So motherboard MB, then config, and in this case half bridge HB, and then max bus voltage supported and max input-output current supported.
Wolfspeed's SpeedVal Kit is a modular evaluation platform that offers designers working with SiC silicon carbide building blocks for quick and easy system level testing. The platform consists of a motherboard, power daughter card, gate driver card, optional control card, and other potential accessories. Designers may test any Wolfspeed discrete devices up to 1200 volts. Here are all the components of the kit. Let's analyze each one by one.
The kit contains all required gate driver cables and MMCX to BNC adapters to simplify probing the VGS and IDS test points on the power daughter card.
Also included is a surface mount SMT current transformer that can be used for IDS measurement on the power daughter cards, a resistor MP821 of 5 ohms plus or minus 1% 20 watts, and it is a through-hole resistor, and an adapter board for compatibility with the NXP control card. And also a cable assembly, ribbon 16P, screw, hex standoff, and so on.
The SpeedVal Kit is a modular evaluation platform that enables the user to perform testing and evaluation on a wide variety of silicon carbide MOSFETs and gate drivers. It operates up to 900 volts and 40 amp RMS and includes the power connections, DC bus, and interface for the daughter cards. The platform can be used for device selection, gate drive optimization, as well as early controls development using an optional control card. Designed as a half-bridge motherboard, this one that I am going to review supports various testing methods, including double pulse testing, DPT, for measuring switching energy, as well as system-level evaluations in common topologies such as buck and boost, both synchronous and asynchronous. Let's analyze the different components and parts on board.
Fan power connector to be used in these white connectors, fan 1 or fan 2, the possibility to have 2 fans, manual fan power switch on and off, 12 volt logic power input, high side PWM input BNC, and high side PWM selector. This is a gate driver interface connector. And the other part, low side PWM selector, low side PWM input BNC, and current sensor sensitivity selector. The SpeedVal Kit half-bridge motherboard comes equipped with 2 current sensors for sensing the DC bus current and the switched node current. This is control card slot. The motherboard supports control cards from industry-leading partners. The Texas Instruments control card can plug directly into the motherboard, while the NXP board requires the use of the included interposer board shown first. This is an external digital I/O connector. It contains 2 digital input signals and 2 digital output signals that can be programmed to interact with external circuits using one of the control cards. This is a remote voltage sensing connector. Then this is NTC temperature sensor connector. These are gate driver board output connectors. Between them there is the ACS 37002, a fully integrated Hall effect current sensor by Allegro to provide high accuracy over the entire operating range without the need for customer programming. Here you go, the power daughter card connector. There are lower and upper drain sense tab, and then positive and negative DC bus terminals.
This is the other ACS37002. This is linear voltage regulator by ST.
And here, on the back of the board, you can see 12 microfarad capacitors rated at 1100 volts. So, that's the motherboard. Let's see an example of gate driver as from my box, as you saw previously. This board is a half-bridge gate driver board designed for evaluating Wolfspeed silicon carbide MOSFETs and modules. It features a Texas Instruments UC-C21710 isolated gate driver with overcurrent protection via a desaturation circuit. Two isolated DC-DC converters are installed on the board for generating the gate drive bias supplies. These ones. The board includes DC supply reverse polarity protection and differential inputs for noise immunity. The user may adjust the switching characteristics by R27, R28, R30 and R31. The default installed gate resistor for both the turn-on and turn-off is a surface mount device, 1 ohm, 1%, 1.5 watts resistors.
The VN pin is protected by a diode and MOSFET in line with the input to protect against connecting a power source with positive and negative polarity reversal.
The UC-C21710 gate driver includes overcurrent protection using a desaturation circuit. This system monitors the drain source voltage of the silicon carbide MOSFET or power module. If the voltage rises above a safe limit, it signals an overcurrent fault. When this happens, the affected gate driver channel is disabled and the gate is pulled down. The fault out pins indicate the fault and the system stays latched until a reset signal is received from the reset input pin. Only the faulty driver is disabled, other channels continue operating based on PWM inputs. The overcurrent detection threshold is set to approximately 7 volts on this board but can be adjusted. The corresponding pin on the driver has a 0.7 volt threshold relative to the MOSFET source. The UC-C21710 gate driver monitors under voltage on the isolated DC-DC converter output rails and the 5 volt supply. If a fault occurs, the affected gate is pulled low regardless of the PWM input.
This is the power daughter card, the TU2474 power daughter card interfaces with one of the Wolfspeed SpeedVal Kit motherboards. To be connected in this way, we can enable different testing, double pulse testing, DPT, as well as system testing in many common topologies. Test points allow for waveform capture of VGS, VDS, as well as IDS. This can be used to evaluate silicon carbide MOSFET switching performance, including measurements of EON, EOF, and core, and so on. By using these cables, you can capture the corresponding signals. A-series RC snubber is placed directly across the DC bus on this board. The snubber helps to reduce noise propagating to the DC bus due to switching of the devices. The board comes populated with the shunt resistors for current measurement. The power daughter card has a pre-populated gate resistor that has been optimized to be the only gate resistance in the circuit. There are two gate resistors. One is connected directly to the gate, while the other is in series with the diode D1 or 2. This allows the user to tune their turn-on and turn-off behavior individually based on the application requirements. The effective value of gate resistance for the upper device is the parallel of these two. Turn-on we have R8 and turn-off is the parallel of those. For lower sides, the same consideration. The devices, 650 volt silicon carbide MOSFET, are mounted on the heatsink at the back side of the PCB. A layer of aluminum nitride thermal interface material is applied between the devices and the heatsink. The heatsink has clips for good contact between the devices and the heatsink.
Just an example of connection. For any information, I would suggest to read the documentation of Wolfspeed. Many of the gate drivers compatible with the SpeedVal Kit platform feature overcurrent protection to protect the MOSFETs in the event of a shoot-through event or short-circuit scenario. This protection requires the drain voltage of both MOSFETs be monitored. The SpeedVal Kit motherboard includes jumpers to make the connections from the MOSFET drain sense points to the gate driver, while this is the connector.
The drain source voltage, VDS, of the lower device can be measured using a BNC connector. Two MMCX connectors for measuring the gate source voltage, VGS, that is the waveform of the lower and the upper device. Another MMCX connector for measuring the drain current ID through the lower device when using the shunt resistors for current measurements. Thanks for watching. Stay tuned.